Hello everyone, welcome to another C++ programming tutorial. My name is Tommy. Today I will be discussing about conversion of hexadecimal to decimal value and decimal back to hexadecimal value, but in this case I will be talking about algorithm. So today I will show you how to write your own algorithm in C++ to convert between decimal to hexadecimal values and vice versa. I'm also aware that the standard hex and standard decimal functions are available, but we're not going to use these available functions for this tutorial. If this is a job interview question, you will thank me for it. So the first example is where you're converting decimal to hexadecimal. Example, converting 995 to hexadecimal value. What we need to do is take the initial number 995 and then divide by 16. Then afterward you will divide the quotient or result by 16 until it becomes 0. So as you can see, you take 995 divided by 16, the result, the quotient is 62 and the remainder is 3. So you keep it in 3 separate boxes like this, and then you take the 62, carry it over, and you divide by 16, and the result is 3, and that will be 14. 14 in hex would be E, and then you take the 3 and divide by 16 again, and as you can see, the quotient part, or the it will be 0, and then the remainder is 3. So if you read it basically backward, from bottom to top, will be 3E3, and that will be your answer. So this is basically, this is how it's calculated, but I'll show you that how it can be done in C++. Okay, so the next part is when we're converting hexadecimal to decimal, you basically begin like, for example, 3E3, right? So you start with the rightmost digit, and then the n power is 0. Multiply the rightmost hex value by 16 n. So for example, 3E3, that will be 3. That's your rightmost value. Then you move one digit to the left, then multiply that digit by 16 to the power of n plus 1, then store that product and keep it to the side. And then you continue multiply each increment digit of the hex value by increasing powers of 16 and store each product. And so once you have completely multiplied each digit of the hex value by the proper power of 16, add them all up. The sum of the decimal is equivalent to your hex value. So I'll begin showing you how to write the code in a few minutes. Okay, so let's jump into Visual Studio Code and create a new directory. I'm going to create a new directory called converter, and inside converter folder I'll go ahead and create a new file called converter.cpp, and I'll explain basically what I'm going to be typing. Okay, so let's declare a couple of things here. So let's do include IOStream for standard input output, include string for string manipulation, include vector for creating these dynamic arrays, include map, include cmath, which is we're going to be using the power function, and we're going to declare using namespace standard. For our conversion from decimal to hex, we want to use a 64-bit integer, so we need to define the biggest unsigned long integer possible. So it's going to be define ulong int 64, and we're going to say unsigned long int. Okay, and then in our class we're gonna name this class called converter. So class converter, and inside the converter class we're gonna have a couple functions. So the first function we want to have is something like convert to hex, right? So string hex string the decimal string that we want to pass to this function. Then we want to convert it from hex back to decimal, so we're going to have another function called decimal. So ulong int 64 decimal, and then the hex string. Okay. In our private section of the code, we're going to create a table, a lookup table, and that is standard map char int hex to dec table. So and we're going to initialize it this way. So if it's a 0, right? If it's if the char character is 0, then convert to 0. If it's a 1, then convert to 1. So you see what I'm going to be talking about. Okay, so as you can see, this is the complete table. So something like an A in hex will be 10, B in hex will be 11, and F in hex will be 15. Okay, so that's our complete table for hex to decimal. Now we need to create another table called actually this is going to be array from decimal to hex. So char dec to hex table, and there will be 16 of these, right? Equal to, it's going to be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, and then F. Okay. Okay, so let's go and implement the function hex. So we're going to declare string converter hex string dex string. We're going to initialize string hex string equal to empty string. Then we're going to declare ulong int 64 decimal number equal to A2L, and pass in dex string dot c string. So this function will convert our dex string decimal string into a unsigned 64-bit long integer. Then we're gonna declare ulong int 64 quotient, and then also remainder. We're gonna check to see if there's an overflow. If the numbers don't match, then we know there's an overflow. So we say if toString decimal number is not equal to the original dex string, then we want to say hex string is equal to overflow, and then we just return the hex string. Okay. Otherwise, we're going to go ahead and do a while loop. And while quotient is not equal to 0 or greater than 0, we're going to keep on looping, right? And we say that quotient is equal to decimal number divided by 16, and we define remainder as decimal number percent 16. So this is to basically calculate the perform a modulus to find the remainder in C++. And then again, decimal number is equal to quotient. Okay, so the algorithm that I discussed earlier is that we want to keep on dividing our decimal number until it becomes 0, until basically the quotient is no longer greater than 0. Okay, then we do hex string insert hex string begin. Okay, and then we want to look up. We could basically do a conversion here, do a lookup of our remainder, and then return hex string. Okay, and that will complete basically our function for hex. And let's go on to the function to convert hex to decimal. Okay, so for hex to decimal, we're going to declare ulong int 64 converter decimal, and we pass in our hex string. Okay, now basically we check for overflow. So if hex string is equal to overflow, then we're going to just return a -1. Of course, this is going to cause an exception, right? And the exception will give us basically the highest number that a unsigned long integer, the compiler will give you that number. Okay, and we're going to go ahead and declare a couple variables here. So ulong int 64 product, okay, int p equal to 0. So this is our power variable. And we say ulong int 64 sum. Okay, and set it equal to 0, and we're going to create a for loop. So we're going to loop basically the hex string backward. So for int c equal to hex string, length -1, c is greater than equal to 0, c minus minus. And we're going to say product is equal to hex to that table. We're going to look up basically our hex string and then do the proper number conversion, and we're going to go ahead and multiply that by power 16 to the power of p. Right, so basically when we go from right to left, the power should increase, right? So we say sum equal to sum plus product, and then we want to increment our power p plus plus. Okay, so we're done basically in the for loop, and now we just basically return the sum. Okay, and then now we want to implement basically our main. So to implement our main, we're going to go ahead and type in int main int argc char argv. Okay, and we're gonna declare converter cvt. Okay, so we're gonna create an instant of the converter, and if we say if argc is less than equal to 1, we're gonna say cout argv 0, and we're gonna ask the user to enter a decimal number in our command line, and then we say exit 1. Okay, now otherwise we basically loop through our array from c equal to 1 to c less than argc c++, right? Then we're going to create a couple of variables here. So we're going to say string hex string equal to cvt dot hex argv dot c, and we want to convert this to a unsigned long again, right? So we can say this is decimal equal to cvt decimal hex string, and then we're just going to print out our arguments, right? argv, and show our conversions here. Okay. And go ahead and do a return 0 here. So you can see basically from our code here, we convert the decimal to hex, then we take basically the same hex string and then reconvert back, and you should see the results. So let's save this program, then open up a terminal. So I'm going to open a terminal, and I'm going to cd to converter, and we're going to type in g++ standard equal to c++ 11 converter -o converter. Okay, compiles without any issue. do an ls, we can see the program. Okay, and so here you just pass in the arguments, right? So let's pass in 1, 5, 7, 14, I'm sorry, 300, 3,000, 30,000, 300,000, 3 million, and so forth. Basically, I could even do 30 million. How many zeros are there? So yeah, 30 millions. So you can pretty much do it up to quadrillion if you need to. But for this example, let's see the output. And as you can see here from our tutorial, 1 in hex is 1, 7 in hex is 7, 14 decimal in hex is E, and then convert back is 14 again, right? So you can see that from the left to right, we convert 300 to hex, then back to decimal, and you can look at basically at a Microsoft calculator and then compare the example, and you should get the exact output as expected. And if you enter a pretty large number, like I don't know, let's say 3 and so many zeros, you should see some kind of overflow, right? And here the overflow is telling us that this is the biggest number that it can receive, you know, without getting an overflow. So I hope that this tutorial actually help you. If you know there's a job interview and they ask you, okay, how can you convert hex to decimal and decimal back to hex, you know how to write your own algorithm. So I hope you enjoy this you know, tutorial, and please remember to press like and subscribe if you like this kind of tutorial, and then I'll see you next time. Thank you very much. Bye now.